Hello, this is Dr. Ramsey, and in this video we're going to discuss part 2 of the Six Sigma overview notes. Hopefully by now you've reviewed the video for part 1. And again, these videos go along with the notes for overview of Six Sigma. And again, I will not discuss every single slide in the notes, so I do suggest that you look through them. And I'm going to open by discussing the Visual Six Sigma textbook. Again, I've shown you a connection where you can read it through the UNH e-library, so you don't have to buy it. You can get it as an ebook. And I wanted to point out that we will often refer to case studies from this book. And that's important because I think the case studies really give me a nice framework for presenting a lot of related material on methods used in Six Sigma and in Lean, but primarily Six Sigma. And that gives you some context around at what point would you use what particular method. So I'm going to go ahead and put the notes on slideshow. Okay. And again, this is the Visual Six Sigma book, and as I said, you really don't have to buy it. If you want to, that's fine, but you can view it through the UNH e-library. And as I said, there are case studies in the book. Actually, in a follow-on video, I'm going to give an introduction to the Reducing Hospital Late Charges case study. I'm particularly going to focus on chapters 6 and chapters 8. Those are very complete Six Sigma projects. 6 in particular is one that I worked on some number of years ago with great success, so that's primarily my chapter in the book. But I will assign the case studies for reading. And as I said, you should read the first 2 chapters of the Visual Six Sigma book. And when you have time, I would start reading chapter 4. Again, in these chapters, there can be a lot of jump detail, and you can more or less skip over it. You might want to look at some of the jump output, but you could skip over the like how-to details and just get a sense of the case study, what it's about, and the activities that are going on. I do show a link to download the data sets. Forget it, I've already uploaded a zip file with the data sets, and they're in the course materials area, so you can download the jump data sets directly from Blackboard. No need to go to this link. Actually, I don't even know if the link is still working. Okay, so I'm going to skip the next slide, and I want to talk a little bit about the book used the concept Visual Six Sigma, and this was really our attempt to update the DMAIC cycle. It's not had a great deal of success in terms of catching on, but when you read the case studies, they're written in the framework of Visual Six Sigma, so I wanted to discuss what it is, and I just wanted to show you how it relates to the DMAIC cycle. So the so-called VSS approach, again, I think it has some nice attributes, but by far DMAIC is still used by the majority of people, and that's more or less the paradigm that will follow during the semester. Okay, and again, I'm going to skip some of the slides, and on slide 47 I wanted to primarily talk about the issue of analyzing data, and as you'll see during the semester, Six Sigma does a lot with data, and the jump software actually is going to make it fairly easy for you to do a lot of the analyses, and this is not intended to be an in-depth or highly mathematical or theoretical statistics course, and we're really just focused on methods and how to use them. But typically today when we talk about getting data and we're trying to analyze it and get information from it, it really happens in two stages, and this is really different than the classical paradigm used in teaching statistics courses. So if you've had a basic statistics course in the past, which is not a prerequisite for the course, then you may have seen the analysis of data presented in a very different and I think very artificial way. So basically what you're going to see is we begin, we examine the quality of the data, and I'm going to show you how to do that. And if there are problems, we'll work to correct them. Okay, in this semester, most of the data I will supply to you, so there really won't be a lot of work necessary to clean up data, but I am going to point out the things you need to be aware of, things that can be problems in data. So we begin by visualization, and a lot of this is what we call exploratory technique. We're exploring the data, we're trying to understand the variables, and we're trying to find hidden relationships between them. So this is sometimes called EDA. That's a term that goes all the way back to at least the early 1980s. But today, because of software like JMP, this exploratory analysis is now very easy to do, as you're going to find out this semester. So we begin by exploring the data, and a lot of it, as I said, is visual, and sometimes just that exploration alone is all that is needed to, say, find the root causes of a quality or productivity problem, or perhaps just to discover some problem in the process that is easily fixed. So sometimes all we need is the exploratory phase in terms of data analysis. Frequently, we'll have to go further and do what they sometimes call confirmatory analysis, or CDA, and you'll see these terms off and on during the semester. And CDA involves statistical methods, and we'll talk about them later on. So if with the exploratory analysis you can't really come to firm conclusions about, say, cause and effect relationships for poor quality or services or other issues in a process, then typically we have to go further and apply other methods. Okay? But I do want that paradigm to be understood. You go from exploration, and after exploration, if there are still open questions about cause and effect, there often will be, we have to go on to use further methods. Now I want to talk again about, in the book, what we call the Visual Six Sigma Roadmap. This was meant to be a more flexible approach to problem solving compared to the DMAIC. It's really based on this idea of exploratory analysis to confirmatory analysis, and we like the framework of Visual Six Sigma, but again, DMAIC is by far, and I mean by far, what people use, so we need to really focus on DMAIC during the course. And again, you should review the DMAIC cycle, since that's really the underlying framework by which we attack problems in processes, and again in terms of products and services, and basically they can be used for many types of problem solving, but we'll focus mostly on different types of process problems. So we begin with frame the problem. Basically, you're identifying the problem, identifying the opportunity that is to be attacked. Then you say you collect data. Collecting data may be actually collecting it. It also may be actually accessing existing data in databases. And then we move to uncovering relationships, and this is really the EDA, or exploratory, part of the analysis. We're using various techniques, many of them visual, to look at the data and see if we can find potential relationships between what we call the X's. And by the way, the symbol X, I'm using a tradition from mathematics. The X's represent inputs to a system. So whatever variables there are in the process, we denote them by X. And the measured responses, the outcomes, are Y's. Again, you'll see that notation a lot during the semester, and it's commonly used in Six Sigma as it is in math and statistics. Well, sometimes the uncover relationships phase is all you need. However, sometimes we have to go further and do deeper analysis, and this will often involve building statistical models. Again, the JMP software really shines when it comes to building statistical models, and we'll show all about how that works later on. But sometimes we don't even need this model relationships phase. And the reason I say that, let me just pull up a pointer here. And the reason for that, again, will put a star by it to emphasize it. Okay. The reason is if we have compelling evidence from the exploratory phase of definite causal relationships between the inputs to the system, the X's, and the response that would solve the problem, we basically can skip modeling. Okay. Then we have a stage called revising knowledge. Basically what this would represent is we'd look for ways to improve the process or manufacturing or service, and then test out the potential solution and implement it. And then finally, utilize knowledge is basically we implement improvements and then we monitor them to see that the improvements have been achieved. Okay. Well, if you read through the DMAIC material or watched the first video, then you can see there is some relationship to the DMAIC. So on slide 50, I try to show you how they're related. Again, I'll primarily use the DMAIC terminology, but the case studies in the Visual Six Sigma book talk in terms of the Six Sigma roadmap, the VSS roadmap. So I just want to show you how they relate. So the first two steps in the roadmap, frame the problem and collect data, are basically similar in nature to define and measure. Okay, so that's how they relate to the DMAIC. The uncover relationships phase actually isn't exactly related to DMAIC. The closest it comes to is what we call the analyze phase. However, what's different about the Six Sigma roadmap is this uncover relationships phase is really much more exploratory in nature than traditionally the analyze phase in DMAIC, but that's roughly how they relate. Okay, and then basically the revised knowledge section is related to the improve phase. I'm going to go ahead and go to the next slide. So when we talk about revising knowledge, we're basically talking about the improve phase. And then the utilize knowledge phase is really a combination of improve and control. So there is a relationship. It's just that the roadmap is more flexible, and there's a part of it you can leave out, the model relationships. In DMAIC, again, this would be similar to the analyze phase, but we find sometimes if you have a lot of data available of good quality, we can really speed up the process and go directly from an exploratory analysis to improve and control, which we call revise knowledge and utilize knowledge. Okay, so I'm going to end this section. I want to keep it a short section, and now we're going to move on to looking at, in a preliminary way, a case study, and I'll demonstrate a little bit of the JUMP software for you.